So friends, let's take our next question, that is question number 7. Now in this question, when you see, this belongs to section of electromechanics, and the question particularly belongs to chapter of current, electricity, carbon code resistors, right? Now the 200 ohm resistor has a certain color code, yes, and if one replaces the red color by green in the code, the new resistance will be. So in order to solve this, friends, you should know the color code sequence of carbon resistors. For that we can use the trick. We have also used the same in January solutions. Let me write that for you. That would be B. Roy from Great Britain has very good wife, right? This is black, brown, red, orange, yellow, green, blue, violet, gray, white. Now for the color code of 200 ohm, what would be? So if you write this 200 ohm, this will be represented as 20 into 10 to power 1 ohm, right? Here the variation has not been asked, so we are not getting into it. So the color code of this would be for 2, 0 and 1, it would be for 2, it is red. Then what would be there? For 0 it would be black. And then for 1, this one will represent what? Brown. Now in the question it has been asked that we want to replace red and we want to make it green. Now what would be the number? Instead for red, if we use green, it would be 0, 1, 2, 3, 4. For green it would be 5, right? So what is number for red? It is 2. We have to replace this with 5. Now the new resistance would be, let me write that for you, R dash would be 5, 0 into 10 to power 1. So that would be green, then black, then for this one that would be brown. This ohm. So among the 4 given options, which is the best suited one is option number 2. It was a pretty easy one. Let's move on to our next question. Now let's take our next question, that is question number 8. This question belongs to section of electromagnetism or from chapter alternating current. This particular topic is LR circuit. Now as per the question, there is a 20 Henry inductor coil which is connected to 10 ohm resistance in series. The time at which the rate of dissipation of energy across resistance is equal to rate at which the magnetic energy is stored in the inductor. So some energy has been dissipated by the resistors which will be absorbed by the inductor, and we have to equate them, and at what time this will happen. So certainly we are going to equate the power of the two, the power lost by resistor and power which is absorbed by the inductor, right? Now it's pretty simple. You should know the variation of current for inductor in LR circuit. So I would be equal to I naught 1 minus E minus T by tau, right? So what is the power lost by resistor? You will write here I square R. Now what is the power which can be stored by the inductor? That is the available power, right? So you will write VI, which is the supplied power, minus I square R. Right? Now from here it is pretty evident that is the power absorbed by the inductor would be power lost by the resistor. So from here I will write VI minus I square R would be equal to I square R, right? So from here if you solve, you will get VI would be equal to twice of I square R. From here I and I will be cancelled and you will get I as V by 2R. Now in the question the supplied potential would be E by 2R, right? It's pretty simple. Now with the relation, if I get I naught, what is the maximum current? It would be simply E by R, right? Because in the circuit, when it is a terms of maximum current, when the current becomes steady, this inductor will be a simple wire, a straight current carrying conductor, and it will bear no resistance. So at that time the current would be maximum at t is equals to infinite. That's why E by R would be the maximum current here. So putting the values here, I will get from this, let's mark this as equation 2 and this as equation 1. I have the relation between the current at any time and the maximum current of the circuit as I equals to I naught 1 minus E minus T by tau, where tau is the relaxation time and what is the value of tau? That would be L by R. So from here if I say I is equals to E by 2R, that is equals to here, that is E by R, 1 minus E minus T by tau, right? On solving this, you will get simply this will be cancelled. So 1 by 2 is equals to 1 minus E minus T by tau. On solving this E minus T by tau, you will get half. So taking log on both sides, I will get T by tau is equals to natural log of 2. I have inversed them. Now from here, it's easy to say that T would be equal to log, natural log of E into L by R. Now what is the value of L here? So if you see, the value of L is given as 20 and R is given as 10. So I will simply write time will be equal to natural log of E base 2 into 20 by 10. On solving this, you will get T is equals to 2 natural log of 2. This is our final answer. Let's see which is the best suited option here. Among the following options, option number 2 would be the right answer to this question. Let's take our next question, that is question number 9. Now, question number 9. The question you see belongs to section of mechanics from the chapter system of particles and topic would be center of mass. Now, from the question, there are 4 particles A, B, C and D with masses M, 2M, 3M and 4M respectively. The positions are placed in the form of square at the corners of the square, right? And they have accelerations of equal magnitude with directions as shown in the figure. So we have to find the acceleration of center of mass. Now it's a formula based simple question. If you find here, you will find that x and y is already given to you. So if you see what is the acceleration of C, it would be written as A I cap. What is the acceleration of B? It would be written as A j cap. For acceleration of A, it would be minus A I cap, and for acceleration of D, it would be written as minus A j cap, right? Now you have to put a simple formula for center of mass acceleration, that is solution. So along x-axis, if you see, the acceleration of center of mass would be ma into acceleration of A along x-axis, mb acceleration of B along x-axis, mc acceleration of C along x-axis plus md into acceleration of D along x-axis, and this whole should be divided by the total mass of the system, that is ma plus mb plus mc plus md. Now beware that we are talking about only x-axis. So if you find that among the 4 particles, which are the ones which are having acceleration along x-axis are only A and C. B and D both have accelerations on y-axis. So for them, acceleration along x-axis would be 0. So putting down the values along the formula, you will get A, let's mark it AX. AX would be, for A, it would be M into minus A, plus for B it would be 0, for C it would be 3M into A, plus for D it would be 0. The whole portion should be divided by M plus 2M plus 3M plus 4M, that would be 10M. On solving, you will get, this is minus MA, this is 3MA, that would be 2MA divided by 10M. Solving this, you will get simply A by 5. That is acceleration of center of mass along x-axis. Since it is along x-axis and positive, I can write it like this. This would be our first equation. Now similarly, we have to solve for y-axis also. So let's start with y-axis. Now we have to follow the same formula, but now this time this would be along y-axis. So I am not writing the formula again, I am just going by the formula we have seen. Now here if you see the 4 options, that is A, B and C, D, A and C are along x-axis only. The y component of acceleration for them would be 0. Now I have to consider only B and D. So what is the mass of B? That was 2M into plus a, and for the d it was 4m into minus a. For both of them will be 0. So I will write for acceleration of y-axis 0 for a, for m it would be 2m into a, 0 for c, then 4m into minus a for d, and this whole should be divided by total mass, that would be 10m. On solving this, you will again get that is minus of 2ma divided by 10m. On solving, you will get minus a by 5, right? And this is acceleration of y-axis, so it should be like this. Now this is equation 2. From equation 1 and 2, it is pretty evident that the acceleration of center of mass, that is ACOM, will be written as a by 5 I cap minus a by 5 j cap. This is the final solution to our question. I hope you have understood this one. Now let's see which is the best suited option among the 4 given ones. So among the 4 given options here, the best option would be option number 4. I hope you have understood the question very well. Now it's time to take our next question, that is question number 10.